In this new series, I'm researching and coding a hybrid LLM with Mamba and Transformer that has potential to have infinite context window, infinite reasoning. We need big context window for reasoning, or billions of tokens eventually. But I think this is the future. This is the way to solve quadratic scaling of large language models, or understanding this and building something similar. Check out the playlist below. So in last video, I coded Transformer plus Mamba LLM in 250 lines of code only. And now I actually added Muon optimizer to that from my LLM, the classic Transformer LLM that you can find in Publish Your Own LLM video. And I want to test what trains better, this with Muon or without Muon. Muon trained it quite well in just 14 minutes. We got this. This is the prompt. The future of AI is, and then AI generates no exception. With a deep breath, you can quickly record everything was understood and made. Actually, it's so coherent. And then Alice, wow, I never thought about it that this is so good. I think Muon is even better, but let's see. Let's train the other one as well. And there is just 255 lines of code. And if we implement Muon, then there is 340 lines of code. Without Muon, just add on W, it seems like it's going to be a bit faster. So maybe 11 minutes instead of 14, but the quality is important. Let's see which one achieves lower loss and better quality. Probably because AdamW is hyper optimized in PyTorch, while Muon we had to implement code here manually. I'm using Novita AI for GPUs, by the way. They have 50% off on 4090s. You can see the link below. But then I said, today I went to visit my friend and then it generated LinkedIn. And then it says quant. Maybe it got the link, the quant trading on LinkedIn confused it. I don't know what happened here. Or we are also generating at the same time while training this, but I don't think that matters. We'll try again. So I'm testing Muon still. This is still Muon. And when I say the future of AI is, it does generate coherent text. But if I say something else, it's still okay. I went to my friend at. It's coherent text. As time went on, more members began telling the very thing they had done. I don't know what is step 10, step 20. This is, I think, skip this and start looking from here, school. So this is just like some generation. Maybe this is just how like the model generates and works, but then this is the generated text below. Because Claude Opus coded it, I still need to check the code to know exactly what this generation is. Now I'm thinking, how do I even test these? I can just see perplexity, loss, and these kind of scores, time to train, steps per second. But if I want to use benchmarks, like even Hella Swag, the easiest one, I think I need to train for longer. The reason Muon one is slower is because it's using both AdamW and Muon, while this current one is using just AdamW. Here you can see Muon plus AdamW, it took 14 minutes and this one took 11, AdamW alone. Loss, this one has a bit higher loss. So is it worth the wait? So this model is too small then to know this. We need to train a better, bigger model and maybe use even benchmarks. LLM one also seems to generate very coherent text. I said, today I went to research, but it was heavily influenced by language and culture. Just think of it as thinking about something and how we make decisions every day. I feel like we have two options. We can start scaling and then add all the benchmarks, and maybe that would be actually better. Or we can just pick AdamW for now because it's almost the same as Muon on this small scale, and it just trains a lot faster. And then try architectures, but I think we need to scale. Like it's about scaling with LLMs. So maybe let's try to run it on multiple GPUs. Maybe let's ask Claude Opus. I want to write a research paper examining this architecture. I want to scale it from this point on, not too much. I'm a single person training on cloud GPUs. What are my options for experimenting? Should I add some benchmarks from Hugging Face? Don't write code, just explain with text article. We can focus on 100 million to 1 billion parameter range, okay? Currently we have around 20 million parameters. I feel like we're just gonna do so many ablations with not only these like parameters, but also changing different ratios within how these parameters where they are in the model. I know Hugging Face did like 4,000 experiments with scaling, but we will not do so many, but I just want to show you the scale of possible ablations. I guess we just create a bunch of different random models. It doesn't even matter which sizes, just create different architectures. Try a bunch of different sizes, bunch of different architectures. Test different layer patterns at small scale before committing to larger runs. Ablation study is critical for your paper. Component ablation, remove SSM or attention layers entirely. Pattern ablation, systematically varied layer pattern. Hyperparameter sensitivity, how robust is the architecture to different configs. So much stuff, oh my god. But this is gonna be a good paper if I do it, but so much stuff. I need to know how to do this even. Initialization impact, does the hybrid need special initialization? We could go to a conference later though, because there is like, if I do all of this, like this easy conference. So I just told it to design some experiments for small scale ablations on 4090, one or multiple. So single 4090 has 24 gigabytes of VRAM, 50 million parameters with batch size 32 at 512 sequence length. I guess this is maybe approximation. 100 million parameters with gradient checkpointing and batch size 16. I think we will do around 20 to 50 million parameters architecture search first. Can run multiple 20 million models in parallel for faster experimentation. Multi 4090 setup, 2x can handle 150 million parameters comfortably, 4x 350 million parameters, or run parallel experiments. Because 4090 is so cheap on Novita, 18 or 19 cents, it's almost free, 18 cents per hour. So I can just run a bunch of them. Phase 1 architecture pattern search, week 1. Setup single 4090 7 days. What do you mean? What do you mean 7 days? 7 days of training? Model size 20 million parameters. This is okay. Training 1 billion tokens each, achievable in 4 to 6 hours per model. I wonder how correct this is. I think it's correct. We want to keep it same 1 billion tokens because when we do benchmarks, we want to do benchmarks while training on the same data. Dataset, we will just use small LM dataset by Hugging Face. We can have all of these architectures. So Mamba, all attention, or Mamba, attention, etc. We will track final validation loss, convergence speed, steps to reach loss thresholds, training stability, gradient norm variance, inference speed, tokens per second, and memory usage. So there is 15 models, 5 hours each, 75 hours, so 3 days, but I'm gonna run multiple in like GPUs in parallel, not just on one GPU. So I'm gonna run each model on a single GPU, but multiple at the same time. Because I don't wanna mess with parallelized code right now. There is no point, just run entire model on a single GPU. Then experiment 2, we take best patterns, maybe top 3, and then we try depth scaling. This is interesting. I guess then we can do some other ablations experiment. This is interesting. We can do also these microtasks, comparing different architectures. Copy tokens from position X to Y, count occurrences of specific tokens, reverse sequences of varying lengths, learn key value pairs, simple math problems, ABAB sequences, completion. If you get this error in LLM Arena, you just need to go and refresh your page here so it reads that you're not bot. Just enter any other LLM Arena page and then you can retry. I created GitHub model, hybrid LLM, and I copied my code from Opus. So I told Opus to create minimal code changes to set up first experiment with layer permutations. Maybe you want to create a new file to save checkpoints to Hugging Face. Also add metrics to measure in this or other file with minimal code and keep it to a minimum but well designed and self-contained experiment. I just gave it these 250 2 lines of code for the LLM, and now it's creating experiment patterns by, yeah. And then run experiments. No, I skipped one. There is analyze results. Here, analyze results. So let me copy that. Go back to analyze results, paste. I also pasted my Hugging Face GitHub Hugging Face repository here. Run experiments sh has all of these patterns 1, 2, 3, 4, 5, 6, 7, 8, 9. Some of these seem to be missing a little bit. For example, this one is missing one M here, and this one also. This is because, large language models, they struggle with tokens, so they try to do these tokens, but they don't see letters. Should we add some more patterns? We can add them later. Okay, use weights and biases. Why is it using that? But this script is very simple. So this is how we use it. We can install these. I added these to requirements, and then Python experiment pattern spy pattern, give it the pattern, and use weights and biases. I did not set up this yet. I can also do debug fast mode. Okay, let's do that. And then run all experiments this way and analyze results. Each experiment saves config, metrics, and checkpoints. Each experiment takes 2 to 3 hours on 4090. I connected weights and biases, and I think it all works. We have this issue with tokenizer. But I didn't run it in debug mode, so let me interrupt and try debug mode now. Now let's run our first actual experiment. Because debug mode works and I fixed some bugs, I'll just run it for 5,000 steps. Why is this warning still here though? This is still not the full experiment, but I want to see if it's gonna get saved properly to Hugging Face, to weights and biases and everything. And I also want to try to use this Hugging Face. I'm not sure, so I see these charts, but I'm not sure from which run, because I'm running the third one now. So this is 150 steps in total, so this is the debug one. But I run a few debug runs, so I'm not sure exactly which one. So it's this one, You see, you have runs, and then if I go here, we have different runs. Okay, now we have different runs. So this one is going on right now. 1,300 steps. Maybe it's gonna report soon. 1,400, yes. And I also have this comparison between different runs. That's crazy. That's crazy. Yo, what is validation perplexity exploding for? What? Everything is crazy. Training loss is going down. Validation loss is going up. What's happening? Validation perplexity is absolutely crazy. What? Validation loss is 9. What? I think validation loss is just improperly calculated, but it's not actually this huge. Train loss going down, but validation loss going up. Look at this. Validation perplexity. And then train loss, it does go down to the value of 0.1. And then nothing is uploaded to my Hugging Face either. Okay, first of all, model is not uploaded to Hugging Face at all. So let it fix that first. I should put my camera here probably so it doesn't cover all of this stuff. So I'm just gonna say to add this code to upload to Hugging Face automatically, make minimal code changes. You need to say that because these LLMs, they're getting fit for long horizon benchmarks like SWI verified, and so they are getting biased towards making long reasoning changes, long code modifications. So just tell it to do minimal. We got a new big chunk of code, upload to Hugging Face. I will trust it. This hybrid transformer model and stuff. I like this. This is what I don't like. Look how much it changed readme. Why did it change everything? Why did it do that? I'm not gonna accept this. You need to set your Hugging Face token in .env file. So like this equals and then Hugging Face token. Just copy it here. And it's also displaying my Hugging Face token in console for some reason. So I just told it not to. Now I will run it in both debug and use weights and biases mode. I like weights and biases. It gives me all of this stuff so easily. It's so easy for me to see. What is this validation loss? What is this, bro? Tokens per second. This is interesting. I never even saw this. 200,000 tokens per second. Finally, I'm able to upload to GitHub. Make sure when you are on your cloud environment, it doesn't commit .env file there. So you need to create that env file with command with your keys on the environment as well. You can use echo or ask AI how to do it. Let's see why my validation loss is going up. Non-overlapping sequences. The text dataset creates completely non-overlapping chunks with 90-10% split on tokens. The validation set sees completely different token sequences that never appeared in training, even though they are from the same documents. Small dataset overfitting. With only 2,000 to 5,000 documents, the model is likely memorizing the training sequences rather than learning general patterns. The validation is technically correct, but it's not ideal for language modeling where we want to test on held out documents, not just held out tokens from the same documents. We got some changes now. It's mainly to the data, as I can see. And I'm gonna keep those, and then I'm gonna apply some to these experiment patterns. And here the changes are also for the data. So we create smaller learning rate because this one was big, I also think, and then some dropout. Fix the non-overlapping sequence issue by adding stride support to text data. Fix the train val split to be by document instead of tokens. We're using a bit of overlapping sequences to train. I'm not sure why, but let's test. Validation loss still seems to be kind of exploding. But next, maybe just the problem with the architecture. So I'm gonna test different architectures and check each one in the next video. But it does seem to go down now. Bro, it does seem to go down. So now I added this command to also set debug steps. If debug set number of steps, it should maybe just be number of steps in general, not debug steps. So I can just set number of steps. Validation loss doesn't seem to be going down, up or down. Okay, I think I'm gonna end my video here. Check out other videos on my channel, and this is gonna be part of a playlist. So see you next time. Next time I'm gonna do more experiments and stuff. So just check the next episode in the playlist link below.